capabilities in-house. So, I've been an architect for 20 plus years, and Craig, who met, introduced you yesterday, also an architect. So I'm a strong believer in kind of software, especially related to Revit and BIM, kind of starts from the architectural perspective, understanding how projects get put together. And so hopefully during this class, it's less about just kind of being a software wonk in terms of, here's where all the commands are and where the buttons are, and a little bit more about the process as you guys start building up, I guess, the firehouse and sweeper. So what I'm going to do, schedule-wise, I'm going to be kind of floating in and out. So I'll be that creepy guy in the back, and if you guys have questions or get held up, I'm going to be here till about 11 o'clock, so I'll help out. Probably interrupt Craig and Brady's flow.
Derail me.
Brady flow. And
Yeah.
ask him really obscure questions.
Watch my face go even redder than it already is.
Exactly.
So, cool. Alrighty, so first things first is on the file. I did go in and kind of get you guys. We touched on floors a little bit. We're going to touch a little bit more today after we go through walls and revisit it. So you kind of gel all of those systems together. As you can see here, some things that I went back in and did for you guys. We did the one trace out of the floor on top of building out just a regular floor and modifying the sub properties of it. So I've gone in and I've actually got most of the floors in. We're missing the last two podium, or at least the penthouse of the building. I also came in and added in the sub-discipline called drawing set. So as we go through this, we'll be developing content on the drawing set sub-discipline within the project browser, and pulled the grids down to only the system, whereas yesterday we had everything down on system. Today it's divided out. One thing I wanted to kind of show you, and it's not until you actually open the file and you don't have the link, is whenever you get, we did a lot of CAD file linking yesterday, and we did some importing too. So there's going to be a lot of times where things go missing or things get moved. So within this file, I want to show you guys how to relink and find the new path. So go to the Manage ribbon and go to Manage Links under the Manage Project area. And then under CAD formats, you should see some new CAD files. So I had to go in and pull these for the actual floor slab edges because of the way you guys set up your X-reps. And you can see it says not found. So when you open up the file, it's going to immediately tell you that you have missing links. We opened up the file for you so that dialog didn't come in. So to find the link, you have to go one by one, and you can do at the bottom reload from. So let's go ahead and reload from. And it's going to be on your Dropbox, so our Dropbox for the course, our makeshift server. So go to the C drive, Dropbox. So that's my Dropbox, so it'll be SGA Training Sweetbird. And then under links, and then it'll be under backgrounds. And then you just click on it. You don't have to actually click the file, just click on open in that folder, and it should find that file for you. And
is it
reload
smart? Does it find the other ones too?
No, unfortunately it's not like Max where it sees that asset and then sees it as an asset and then lets everything else pull from that asset. You actually have to go one by one with it. But it does remember your history. So you can always just go ahead and click on open from there then. And it with the link, it's going to stay there regardless of if you resolve the reference or not. There are some cases where it'll completely unload it if you save it. But you should still see that CAD file even if you don't choose to relink it. In our case, we kind of want to keep the integrity of the file as we go through the process here. So once you have that, just click OK.
So you can unload it and have it there.
Yeah.
The path remain the same, but you can always...
Exactly, and we touched on that yesterday where we unloaded the one link that we had and then we went and imported the other grid files. As you can see, I also removed that kind of switch on this file. Okay. Yeah. So that's all the things that we did last night for you. So on the what do we want to talk about today, at least until break time at 11 here, is really about walls. So as if you remember from yesterday, I said that walls, floors, ceilings, roofs, they're all a system of assemblies. So you're basically layering up a wall system to mimic what that wall is actually made of. So I've prepared a sample file so we can kind of walk through walls first, and then we'll come back into this file and actually draw the walls for the project as you guys have designated in the CAD plans. Maybe build out a floor while we're here. So let's go ahead and go to the R, go open, project. And then on your desktop, should be a Sweetbird session or a session 2 folder you see. So in my case, mine's still in my Dropbox. So it'd be the session 2 folder, and then you should see a wall examples, session 2 wall examples in there.
It's supposed to be on desktop? Or?
Yeah, you should see a session 2 folder. If not, if I didn't get a copy, just go back into the Dropbox and you can open it from there and save it down to the desktop.
Okay.
Either way, I just want to make sure that we're not all saving into the Dropbox and overwriting files. Yeah, it should be quick, 2-second copy paste. I thought I got that one. Does everybody else see it? Yeah. Go ahead and open that file. Alright, so it opens you up to a 3D view. And remember, I can hold shift and middle mouse button, rotate it around, so we get an actual good view of this. Alright, so how walls work is Revit out of the box. If I select one of these walls and look at its properties, Revit out of the box allows you, just like floors, I can do a multitude of types. So we talked that there's globals and then there's regionals. The global would be a basic wall, a stacked wall, and a curtain wall. So we see here the basic walls are each of these. The stacked wall is an assembly of the basic walls, and then the curtain wall is the kind of one-off that allows you your gridding systems and everything else. So those are our kind of globals for the wall systems. And then our regionals are different typologies within each global. So in this case we have a basic wall. So you'll see in the properties it says one basic wall, and then the regional property of it is SGA concrete curb wall 6 inches. If I look at the middle wall with the door in it, it's going to say stacked wall, and then that's our tutorial stacked wall. So that's our global, which is stacked wall, and then our regional is the actual sub property or the type of that wall system. And if I select the curtain wall, you'll also see that as designated as curtain wall. Now with the curtain wall, it does provide you 3 other globals. So if I was going to go and make a new wall, so I would go to the architecture ribbon and I would click on wall. When I pull down from the properties and I scroll down, you'll see that there is, well, out of the box you're going to have 3 other sets, right? One's going to say in this case it's not in this file, it's going to say storefront, the other one's going to say exterior glazing. All it is really just a derivation or a derivative of that original curtain wall system. So within that global you kind of have, I'll call them moons, right? So your satellites of that. And one's just loading in mullions, the other one's just loading in panels, the other one's just a flat piece that's waiting for you to do anything with it. And that's kind of what we see in that final one there. So let's go ahead and go to a floor plan view. And let's kind of try and recreate the systems we have here. So we'll go to T, second floor there. So when I hover over the wall tool and pull the drop down, there's 3 ways we can make the wall. One's a structural wall, so your foundations, things like that. Structural engineers are going to use this more often than you guys will. In most cases, you'll just use the architectural wall system. When we get into really, really funky form geometry, double curvature, things like that for wall faces, I'll let the little graphic come up here. You'll see that I can actually mass out. So that idea that I'm taking grids and hosting grids to, or hosting objects to the grids, such as the floors. The scope box was controlling the grid, so there's that hierarchy that one thing has to be hosted to another. The same goes for any system that's really not orthogonal in this case, and has double curvature. So I can actually host a wall to a massing element that derives that form, and then I can really get to anything else we want. And we'll touch today on some really kind of double curved surfaces as we do imports and things like that.
And just so you know, the wall structural and column structural, these are components that have analysis information embedded in them. So, Revit as a structural tool can be used as a structural frame analysis tool. So the structural engineers can use it to build a frame, run their forces, calculate sizes. So 99% of the time you're always going to be using it for walls.
Exactly, and so to make a wall, it's fairly simple. Most people, when they open Revit, first thing you see is the wall tool. So you start, clicking and picking. So let's go ahead and click wall architectural. And if you're a keyboard person like I am, it's WA on the keyboard. So go ahead and click on that. And then before we really do anything, again, there's 3 ways to skin a cat in Revit. So I have my drawing operations at the top right, which is my line tool, my rectangle, polygons. Again, we went over most of this. I can pick faces, so even if I don't use that wall by face, I can still come in and use the pick face. I don't have to go back out of the command and come back in. I can use existing CAD lines, so today we'll work a lot with the CAD plans and picking lines, so we'll save that for a little later in the process.
I have a question about that.
Yeah.
Is it, when you're setting up a CAD drawing to convert to Revit, it's best to have center lines of walls or faces when you're picking lines?
When you're picking lines, we'll touch on that later, but to answer the question briefly now, it's really dependent upon what you're trying to do. If I'm on an exterior, and depending on what lines I used, if I'm on a CAD plan and building off of them, if my CAD plan goes all the way out, and I've drawn it where I'm building, walls out to the slab edge, then I would be doing, finish face exterior, or vice versa, finish face interior. And I can always tab through and change that. Really, that's just going to determine, and you'll see a little later as we get into the assembly of these walls. If I have a brick veneer on the face of one and then gypsum on the other side of those core boundaries, which side is it going to appear on? Most of the time, if I'm doing the CAD space plan and I'm coming in and then bringing it into Revit and going to, build my walls off of it, I'm going to do everything on center line, and then I'm just selecting everything and letting it populate. But then again, it's really dependent on what you're doing and what the level of detail is of the pieces that you're pulling from. Because it doesn't have to be CAD lines. It can be, floor slab edges. It can be other walls. It can be, pieces of millwork that I'm picking lines off of. It really can be anything. It's that exists in
I see it
Revit.
right there, location line.
Yep.
Yeah, never mind.
An example might be, where wall center line, you have the different options. There you go.
Yeah.
Core center line, finish face, exterior and interior. Think of it like your control line. So if you're drawing a corridor, double loaded office corridor, the corridor is 5 foot wide. You're not really sure, is this a 6-inch wall, an 8-inch wall, the corridor wall? You might set your exterior, finish face exterior on the edge of that corridor wall. So that way, as the wall grows, it grows into the offices, not into my 5 foot. Right? So there is, you can build a Swiss watch and start to really get detailed, but obviously when you're just doing schematic layout, you're not as concerned, and like Craig was saying, you'll just blow through with wall center line and align walls as you need it. But you can build it a little bit smarter.
Yep. Again, it's like Aaron says, the Swiss watch. How much do you want to put into it at the forefront? So, and that's kind of a good lead into kind of this options bar. So if I most of these options that you see, so I kind of describe the options bar as Revit's way of kind of sneaking into things that they really didn't have a good solution to put anywhere else. So it's a really good thing to pay attention to, that anytime you enter command, you're going to get this options bar. So if you want to preset options on your walls, so in this case, if I were going to go draw a wall, right, I have properties here, which is basic wall. Those same properties that you see here, you're also going to see here as well. So it's a little bit of a redundancy. If you're moving like I am, where I'm using project browser kind of tab format for my properties windows, I'm probably going to use the options bar versus using clicking back and forth through properties. But then again, it's really, you can do either or, right? So just be aware that anything that we have at the top here, I'm going to have at the bottom as well. I find it kind of difficult to talk about these first until we actually have a wall to really kind of manipulate with. So let's go ahead and do a rectangular wall. These are kind of just straight line walls. Let's actually build out a rectangle box here. And it doesn't matter the dimensions right now. Okay. I'll zoom in on that wall. Right, so right now it's, if I select one of them, it's got its property of basic wall, wall 1, right? And again, all the properties that we've seen when we're going to make those walls are also here. So let's go through and just kind of walk through what we can actually change just at face value without editing the properties of that wall. One is location centerline. Am I moving it? So at some other time I can actually begin flipping that if it actually had a face or didn't have a face. And as Aaron was describing with the corridor, being able to make that wall grow from inside or outside, we can change that on the fly. What its base constraint is. So we learned yesterday with the floors that the floors are then hosted to a level. So the walls, at least at the base, are also hosted to a level as well. You can, I don't believe they always have to be really hosted to a level at the base at least. The tops are the ones that you can either leave hanging or not hanging. So we also see the next line item is top constraint. So in this case, I don't have them constrained to a level. I'm leaving the height change. And there's going to be cases where that is advantageous for you, and there's going to be other cases where it's more work for you to go backwards with it. So kind of at a forefront, I generally, if I'm schematic design, just getting things up and making it look correct, I'm actually bringing them up and connecting them. When you get into actual partitions and speccing those out, there's going to be cases where you are connecting or not connecting. And then if I go to copy my walls up from level to level, you'll run into issues when you have it. Like if I move a floor or I need to change the level height and everything's constrained, all of a sudden you get a bunch of warnings later down the way. So just be aware that you can pigeonhole yourself sometimes by connecting them. So there are advantages and disadvantages at any point for this.
If you connect it to the floor above, is it connected to the bottom layer of that assembly or to the core boundary of this?
And that's a really good question. So,
Can you define that?
You can define that. So if I brought this up to level T4, you'll see my unconnected height goes up now to 24 foot 4 inches, and it grays that out. So I don't have the ability to change that wall's height dynamically. It's connected to that level. So to change that wall's height, I'd have to change the height of the level, and then I would take my offset and do a negative. Yeah, I would do my negative, whatever my slab
thickness is. But if you do attach to the top and the base, it does take the thickness of that assembly.
Yeah. Also, too, is if I have it so. If I have it so I'm, trying to fluctuate that idea, so some are going to go up, some are going to go down, remember we learned about reference planes, so I'll draw a reference plane, and then I will align that to the reference plane, and name that reference plane out, so I know that that's where my walls are sitting. They're not actually on a level, and then in this case, I would leave that unconstrained, and then control the height from that reference plane, so I can grab and push and pull it from there.
So you said you would do that by aligning it to the
Yep, just like we did with the electrical boxes on the house, yeah.
And you would do that to the base of the wall and to the top of the wall?
Not to the base. The base you would still constrain to the level. Yeah. It's gonna always be defaulted to the constraint of the level. And I can offset, just the way I can offset to make up for the slab edge or the slab thickness, I can make up for a base offset if I chose to do so as well. Say I lay a structural floor and I'm actually building this out, my floor in layers, so then I'm doing my finish as a separate floor assembly. There may be cases where I want to have that offset from that base level to actually have my finished floor go underneath the wall or vice versa, not go underneath the wall. Okay. And then as we go down, there's also other things happening within the walls. What's the length of wall? And that really is determined by, if I select at the top here, you'll see that's going from center point end to center point end. So that is kind of leading into this idea of a wall joint. So when I make the wall, if I disconnect it here, right, the wall doesn't joint. The minute I come up and it sees another wall, and that's really kind of the power behind the wall. So once I even connect it there, it's gonna make that return happen for me. So if I want to turn off that relationship, I need to come in down here. If I click on that guy, bring that out. And you might have to help me out with this one, Aaron.
On a wall joint, you right click on the grip.
Yeah, there we go. Right clicking on the grip will then disallow that join. And then you'll see that it actually allows you to come in that way. And if I want to bring that joint back,
If you have two different wall types joining, then it won't by default join them, right? It'll show the two colliding.
exactly.
And you'll see as the joins can get complex. You'll see when Craig starts to open up the properties of the wall, you'll see the boundaries in terms of the layers of structure within the wall. And so it matches, there's a hierarchy of what it joins. So for example, if you look at a higher level detail, it wouldn't join a layer of drywall to a stud layer. Right? It would join the finished layer to the finished layer.
Right.
Structural layer to the structural layer. So
Cool.
So yeah, and I think that's kind of where we want to go now with it. So if I select out this wall, let's make two different sets of walls so we can actually see what happens when those wall joints happen. So remember yesterday we talked about the core boundaries, where our structure lied, where our finish lied, but in the floor assembly we really didn't have much to join up with it. So I think the walls really do start to explain that idea of the core boundary. So let's go ahead and select one of the walls, and there should be a series of walls already made for you. So let's pick, let's do this exterior brick on metal stud for the top two systems here. And then on the left, let's change that one to be the SGA core 12 inches. Actually, let's do let's make one a partition. So the SGA.
you're not seeing the level of detail that Craig's showing, so down at the very bottom, you can change your display detail level. So change that to fine. You can see.
Is there a reason why I wouldn't see witness lines sometimes and sometimes you do?
On the dimension strings?
Yeah, that.
So how about
But normally that's that you would type it and change.
Yeah. Normally, and that's a good thing to kind of come back to. If I wanted to change the dimensions of this, to make this thing go wider, I need to select the wall opposite of the dimension that I'm actually doing. And then I can click in, and anything that comes up blue or highlights blue is a dynamic editing element, and I can actually make that then wider. If I want to actually put on the dimension string to that, I can click on the little dimension string button on there, and it'll actually implant that. And once I do that, I can't change the width or the length of that by that dimension string anymore. I need to come in and actually
Again, the dimensions are associated with the object.
Yep.
Click on the object to change the dimension. Did you go, and yesterday,
We-
you went over in terms of entering dimensions?
That's one thing we didn't touch on was dimensions yet. I figured we'd wait till we got to the walls.
Just in terms of, moving that around, you
Yeah.
can enter a lot of different ways to enter dimensions where
14.
by default is 14 is feet. So just typing 14 is 14 feet, so you don't need the dimension, you don't need the tick. 14 space 5 is 14 foot 5. You can do decimal, you could do metric, if you want to type 5 meter, 5m, 5 meters. You could do equations, equals 15 minus 4. There's a lot of different ways to enter. Obviously, the faster you are, kind of the easiest way to enter information. For example, entering inches would be 0 space and then the number of inches. So
Is there an ortho?
all those times that you can avoid using the inch and foot mark adds up. I think it'll add about 4 months to the working life.
Sorry, doing what?
I'm not so sure on the math on that, but I really think, from an efficiency standpoint, it really saves hard.
That's a good way to quantify it.
So you're welcome.
Okay.
Thank you, Ray.
So you were asking about ortho?
Yeah, also when you move something, I was noticing if you just click on an element and start dragging it, it moves.
Yep.
But then you have to hold down the mouse while you type in the dimension, which is a little.
Yeah, if I wanted to move this particular element without using the
I
dimension
guess
string.
it's better to say NV. and then do
Yeah, I
it.
can do MV and then actually move it from a reference line or a reference point. So
Right.
I'm actually saying, okay, I want to move this wall a specific distance this way, not by growing the whole assembly of that rectangle as well. Yes.
Can you type everything?
Yeah.
So there's a button right down here that's press and drag.
Oh, good.
So one of the first.
Get rid of that.
Yeah, exactly. And I think John Castro also recommends, and I think it's a classic newbie move.
Yeah.
Which is you don't really realize that you just drag a core wall or drag the lint file or drag something accidentally. So press and drag in terms of turning it on and off. I'll leave it up to you, but just be aware of it.
But John says to leave it off, preferably.
Yeah, I think so. I think,
Yeah.
It's a safer move.
Yeah, we talked briefly about that too yesterday. It's a good reminder because you will do it once in a while.
Yep.
Quite often, actually. I still even do it. Okay. So about wall joints. If I look at the bottom here, and I have this wall. So again, I need to change this last wall to be, let's change it to the 2C 2-hour shaft wall. So we have double-sided gypsum on each side. Okay. And you'll see when I do that wall joint, when we open up the properties of that wall, there's some things happening. So on, and to kind of backtrack, TL for thin lines, and then also at the top here is your toggle for that as well. So it's kind of like the AutoCAD line weight button. You can turn it on and turn it off. So I generally, when I'm looking at the wall assemblies, I'll turn on thick lines or thin lines in that case. So you'll see some things happening. I have a core structure, we know from when we did the floors, that I can have a core boundary, and then I have some finish layers happening, and each one is joining up with a successive layer in a certain way for a certain reason. In the bottom right there, we told it not to allow that joint, so we don't see any joints happening. So let's kind of look at why it's happening and how it's happening. So if I right-click, not right-click, but select the left wall, and then let's go to Edit Type on that wall. So we're editing the SGA Type 2C 2-hour shaft wall. And we're gonna come back to all these other properties. Let's just go straight into the structure and edit that structure. Kind of get that over there. Okay, so we have a core boundary, which is our structure, which is the metal stud layer, and it's at a thickness of 1.5 inches. And then remember yesterday we kind of touched on the differences between finish 1 and finish 2. And I can also, change these to substrates, thermal air layers, membrane layers, all the things that you would have in a system assembly. So what's happening with this is that on my finish 2 layer, most likely corresponds with, if I know I got 2 finish layers, that's corresponding with the left side there of my wall. And I'm going to cancel out real quick and just zoom in a little bit more for you. There we go. So that's corresponding with this side. So that core boundary, right, is really defining that center portion of that wall. Chances are, if I look at the properties of the wall that it's joining with, this is also that core boundary. So core boundary structure is always going to join up with the other core boundary. Right? And then anything on the finish side, so finish 1 here is going to join up with this finish 1 as well. Now this may be finish 2. And that could or not prevent that joint from happening or not happening, and that could be why we're getting that line. And then also, so we should probably look at then the second one and see what those are designated as. So let's cancel out of that, right? Because we're getting those happening, but it's not actually joining up, and that's possibly too is that there's 2 separate materials also in that case. So if we look at this one, which is the basic wall that we put on there, and I edit that structure, there's a whole other set of things happening within this wall system. I have finish layers, I have membrane layers, I have my core boundary, which is structure, metal stud layer on that one. Also substrates, membrane layers, thermal air layers, and then my finished brick. So the finished brick we touched on with our materiality yesterday in the floors. It's most likely this thicker one, and it's the thickest piece there. So we know that that's that area on the wall system. So that's labeled as finish 1. And then this one is actually labeled as finish 2. So it's still going to always go back and trump whatever's the farthest one out in the system. So kind of you don't have to be as aware of it, but it becomes more pertinent when you're dealing with multiple gypsum panels and things like that. When I'm doing interior partitions, you're really going to see that situation happen, and the relationship needs to be really kind of paid attention to when you're at that level of detail.
And I think you have to consider what drawings do you see later in drywall. In a lot of cases, I recommend modeling to things that show up on quarter inch drawings, quarter inch elevation, quarter inch plan, what kind of detail shows up there. You would never see layers of finish necessarily. And if you wanted that detail represented at 3 inch, do it as a drafting view. There are certain cases where you do want to be specific about how walls join together, but as a rule of thumb, I stick to the quarter inch in my head. For me, it makes the most sense in the model with quarter inch detail. Anything beyond that, do as drafting a call out view, right?
So are you saying that you use a dumber wall, or are you saying that in the case if you're doing like a 1/32 scale?
No, I guess what I'm saying is, so this can get really down into the weeds in terms of how various layers of a complex wall assembly can join together in terms of whether this finished layer of drywall needs to join with that and this runs past, right? You can spend a lot of time kind of making those drawings perfect, but in a lot of cases you'll never see that on a quarter inch plan. You won't even really see that maybe on a half inch plan.
Yep.
And so I guess what I'm saying is you're always going to have this is important from a material standpoint, from an assembly standpoint, but in terms of how that's finished and joined, think more on the macro side.
Yeah.
I don't know if that answers your question.
But when you just change the function
Yeah.
He's just saying not spend a ton of time worrying about.
Oh, yeah.
Yeah, unless it calls for it, don't
I mean, 'cause
fuss about
You
it.
would never
Correct.
draw
Yeah.
detail
Oh, okay.
using these walls, like you would do a drafting.
Yeah,
model.
yeah.
Yeah, and to kind of recap from yesterday too, is we, you know, backing out of this was this coarse scale fill pattern with the floors, right? You know, I'm doing a full building section. Chances are, and that's could be at a 1/4 inch, could even be smaller. Chances are you're not going to see any of that. So I always draw most of my things at a coarse scale, and then bump it up when I need to bump it up, and we talked about that. So even so in this case, you know, I may even come in and change, you know, that to be a solid hatch and just let it be as is. Could be all white, could be all gray.
But that being said, because, you know, what we're looking at is a 3-dimensional model of object, that there's an interior elevation maybe that's looking at that face. So whether this brick comes all the way to there or stops here, obviously it's important, right? Because it's being represented as an elevation. Or, you know, if you've got a perspective camera view or you're doing a render, you know, what that actually modeled looks like can be important.
Yep.
So there are multiple answers, but what I'm just trying to say is to not, I see some fear of like, Revit's insane, why the hell are we trying?
Yeah. Yeah, and I think, and you're absolutely right. I think that's why a lot of people immediately make the comment that I have to know all these things ahead of time. Then it's really kind of incorrect. It's more so that it's set up for you to put that information in at a later time when you do know those answers. You don't have to know those answers right away. Okay, so let's go ahead and click apply on that and let that go. All right. So one other thing about the wall joins, right? I can take, and if I move this wall, so I'm going to do MV for move, and I'm going to move that wall inside. So I need to actually disallow that join to move that wall in. So I'll right click on my grip. So here's my grip on that wall. Right, that grip is going to allow me to push or pull that in and out. As I push and pull that, you'll see, because we had the difference in the actual finish assemblies, when I push and pull that grip down to individual layers of the other wall, it's going to join up different sets of information, right, of those layers. If I want to keep that from not joining at all, on that same grip for that wall, I'm going to right click, and it's going to bring up the menu bar, and it's going to be a disallow join. If I disallow that join, nothing will join in that wall. And I'll do the same thing at the top. And I should be able to move that wall into the interior space there. Now if I want to bring back the join, I can click on the grip at the end, and I should see this little symbol. That little symbol is for rejoining the wall together. If I click, you'll see that it then brings finish 1, as that was designated in that wall assembly, joins up with that finish 1. It's vice versa on the other side. And I can do the same thing at the bottom here. Let's go ahead and go to a 3D view. So again, to get to the 3D view is up at the top. So here's our box. So the next step is really kind of understanding that there's going to be cases where you want the wall to have certain openings in it. Maybe the wall profile is slanted in some way. Perhaps you know, maybe it's something as you see in the example here. So to edit the profile of a wall, or to put a wall opening in it for this case, if I select the wall that I want to put a hole in, I bring up my modify bar, and within that modify bar I can edit the profile of that wall. And then it brings up that rectangular piece. So if I want to slant my wall, I can take that profile down. And because it's made from a system family and it's drawn with the wall tool, it's going to have a certain set of constraints, and those are orthogonal to the rectangular set of the wall, and because we gave it a height of 20 feet, right? So we'll say remove constraints when we do that, and I can bring it down. And it's key, just like the floor, the wall needs to always have a closed loop when it does make it set, right? And I can,
Closed loop, and it has to be in the same plane.
yep, yeah, it,
So one thing Craig was doing, so what we're in right now, and floors, you did the same thing. You can tell we're in sketch mode, right? Because everything's gray. You've got these lines, which are sketch lines, and your context menu changes. Now we have a draw menu where now we can draw from that to re-sketch our boundary as necessary. So part of it can be editing the existing lines, some of it can be drawing new lines, and in the same way on floor, you have a check or an X to finish and close your sketch mode.
yep. Who wants to be a millionaire? Okay, so then you'll see then when I made that hole in that wall, some things are happening. Is I'm seeing now the internal side of that wall, and if I look at the end of that wall, I'm also seeing kind of the gray value. So as we kind of alluded to a little bit prior, is that how I'm wrapping ends, and do I want to see the interior of that wall, or do I not want to see the interior of that wall? That looks fun. If I go into the properties of it, so I'm going to again edit type of that wall, there's some wrapping options. So I have one, wrapping at insert. So anytime I put a wall or I put a window or a door into it, that's considered an insert. It could even be an actual opening that I've created. It's going to be termed as an insert. Anything at the end, so when the wall finishes itself, is it going to wrap that exterior structure around? Is it going to wrap that gypsum around the end for viewing? Could be a concern at a lot of points. So I'll go ahead and say that wrapping at ends, I'm going to say it's an exterior function, and I'll click apply. And you'll see that then that exterior surface now wraps on all cases of this, right? And I believe if we do interior for this case, it should wrap the interior side around. And you can see also now when I look at the properties of that, you'll see that it's treating that cut profile a lot differently. So we can
Where's
also
the wrapping? Oh, it's in the.
Yep, there's two ways, and there's two places you can.
Type properties of the wall.
Gotcha.
There's two places you can access it. It's one, I can access it right through the type catalog here in that first dialog box, or I can come into the actual structure of the wall and begin changing it right as I'm creating the wall assembly itself. One other thing, as we viewed as we also viewed the floor, at the bottom left is this preview option. And that preview option gives me the ability to look and plan at kind of what I'm building at that time. So at this case, you can see that it's wrapping at finish, and then I'm pulling my exterior around. If I go to interior, you'll see that it flips my interior gypsum around to the top. So the brick is what stays, and it flips that around. Shouldn't see anything on inserts in this case. So in this case, we'll do both on that. And each one's going to do a certain set of different information. So let's go ahead and put a window into there and actually see what kind of happens with that. So on this wall, walls are windows and doors, right? Once we get into family editing, we'll touch more on how to create them, how to edit them. For face value, putting in.
When you're
Yes.
wrapping, for example, the exterior material into the window,
Yep.
it's not actually putting a brick into the window though, because when I took a section through it, it's just thinness.
Okay, so you're asking, let's see here.
See your window over there on the
Are you talking the window or the hole?
The whole,
The hole, okay.
I guess my question is.
Doesn't turn a course into the opening.
Exactly. There's not
just red material. Yeah, it could be because it's circular and not rectangular. There's probably one reason why. Let's try, as Aaron said, let's try putting in a door or a window and looking at that. So again, to put the window in or a door, they work both. They're basically a wall opening that then has geometry pushed into it. I'll go into window. Again, let's all save our projects. Let's not all save our projects because they're coming from Dropbox.
Let's take this further. If I wanted a material property to show, so for example, if I have a wall that has that insert and I want to be able to see that layer of brick as a single course of brick in a rendering or whatever, if that's important, then what I would do is I would model it as two walls on top of each other. So one the backup wall and one the finished wall. And then I would cut both. And that way I can really control that layer. So, what you're talking about, I think, is a higher, for rendering and a higher level of detail than what's built. There are different ways to do it. I think if I wanted that to look a certain way for a reason, I would build it differently.
Yeah, and I'm assuming kind of what you described was a soldier course around the circle. I would model that actually even in place and do that way. Collar wall.
Yeah.
It gets you 85% of the way there.
Right.
Okay, so again, and this is kind of a lead into some things we'll talk about later. So I'm going to go ahead and click on window. It's going to say that there's no window family. So again, just like AutoCAD, there's our families are blocks, and they're just treated a little differently. So we're going to go ahead and load a family. And you should be defaulted to a Revit library. So Revit libraries this comes standard out of the box. There's several SGA libraries already created. When you get the template, a lot of them should be already created. This wasn't created from the template, so we need to load in our own. So I'm going to be on the Imperial side, and everybody should be on the Imperial side. And I can scroll down. So just like we seen in visibility graphics, all of our families are now categorized by that same kind of designation of typology. So I'm going to go ahead and go down to Windows. And we'll just do a fixed window for this, that's fine. So I have fixed RFA. Now, and this is still kind of a little jumping forward. One thing to note is this last little piece of the file extension is RFA. So we're in an RVT, which is a project file. RFAs are going to be family files. We'll click on open. So that loads our window. Now it's going to track anytime I'm able to put a piece into another host element. So right now the wall is going to host that window, right? So it's only that window I can't place out here because there's no hosting element. The window's always going to look for a host, which is in this case the wall. Go ahead and push that in.
If you wanted a freestanding window, you would have to create a specific family that is not hosted.
Yes. Let's go to the floor plan, T second floor. Now in T second floor, I don't see my window, and that's because the window height is above our cutting plane. So I need to come in and back in 3D. So how do we get back? Control Tab in the keyboard to our window. And I'm going to move my window sill property. So just like the walls, the windows have properties as well. And in our case, we want to move that sill height down. Move that down to 3 feet. Then when we do Control Shift Tab to go back, we should see do an elevation view here. Ah. 14'6", huh? Yeah, I think it's a cut plane. So let's go ahead and just make sure. Yeah, that's why. Yeah. So let's everybody. So one thing we didn't really kind of touch on is my view. Right, it has a cut plane. Default should be at 4 feet. On this particular view, my floor level plane. So I'm going to deselect everything in that floor plan view, and I'm going to go into the line item that says floor range under the properties of that view. I'm going to go ahead and edit that. And then my cut plane is at 1 foot. So I want to make sure that I move my cut plane up. Now each one of these, right, is dependent on the other one. So this one I have an offset of 2 feet. Yep. It'll be under extents and then view range and edit. My top should be a level above. Do 7 foot 6 inches for that, should be the default, and then 4 foot, and then my bottom should be 0 feet for that. So then it cuts through my object.
Your view depth was 0.
Yep.
You can set it at 0, so you're not looking below, beyond the floor.
Right.
And your view top, so there's a great graphic in the book that shows, if you have a whiteboard, cut plane is pretty obvious, right? That's where we're cutting horizontally. It's a plane, so it's in one plane. Our top zone is basically a zone that resides above the cut plane that shows how far up we're looking, and then how far down basically we're looking for line work to appear. And we're not, if that zone is moved up, then we're not going to see any line work, for example, a stair. And we're not going to see the stair sitting below unless we extend the bottom range of our cut down. So with plans, it's looking down. With RCPs, reflective ceiling plans, we're looking up.
So everybody got this matching? Okay. All right, so again, looking at the insert now. So I've come in and I've put in a wall or a window. So that is designated as insert. Because if I go to edit type on my wall now, on my assembly here, because let's edit the structure, because I've decided that both handle that inserts, you'll see that the gypsum wraps as well as that exterior wrapping to the inside. If I chose it to only wrap as exterior, and I click apply, okay, on that, you should see now, okay, that should change then. So now my drywall runs up to that window, and then the exterior runs in. If I wanted the opposite to happen, when I edit that type, and I say that I want interior to happen, and I click OK, click apply, you'll see that interior wraps, exterior runs up into that. And then if I say none, there's going to be no wrapping at that insert, right? So all pieces will run right into it. And again, like Aaron said, this is kind of fussing about some things. Sometimes it's too early to be fussing about these. Sometimes it's not too early to be fussing about them. Same thing happening with this object, right? Because even so that I've made a cut in the wall, even that I've made that cut because it's handled as an exterior function and not an insert, that opening is going to be treated with the end wrapping, not the insert wrapping. Okay. All right, so we got two systems of walls here. The next type of wall is going to be a stacked wall. All right, so within the stacked wall, let's go to the 3D view. A stacked wall is going to be a separate set of assemblies that have all of the basic walls combined with them. So cases where you would want to use a stacked wall. In this case, we look at the bottom. Maybe you have a different facing across the course of that wall. Maybe I have a staggering within it. In this case, I have limestone at?
Sorry.
That's okay. You know, perhaps I have a different stone versus brick on the wall. Maybe I have an instance where things are moving within the boundary of that wall. It handles openings the same way as you would handle doors as well. If I look at the properties of this wall and I edit its type, you'll see a different set of information. I don't have the same kind of face value options at it, and that's because each one of these cuts is a different assembly of wall. So I make my basic walls first, and then I take my stacked wall and I begin, just like the name says, stacking these options up in the wall system. And then the core boundary really comes into place, I think, within these more so than even with wall joints, because if I need to have that stacked wall continuous, I need to really pay attention to where that core boundary is laying, how my finished materials are watching. So in this case, you'll see my preview window also shows this in sectional versus showing it in plan, because really it's more about a sectional property in the stacked wall versus the plan view, which was in the basic wall. So I'll go to edit that structure, and this is also different. So again, it's taking in, just like we were going to put in a material to that wall. In this case, I'm taking different sets of walls, which are basic walls, and I'm able to put them into my stacking configuration. So in this case, maybe at the top, I don't want SGA CMU retaining wall. Maybe I want to do a CMU on metal stud. I can change that off. And you'll see that the variable heights, we'll go ahead and create our own out of this, but paying attention to what heights are controllable. Anytime you have something that needs to vary, at some point within that wall, you can define heights of specific wall sets, but one of them also always has to be variable. And that's so it can have the ability to stretch and flex in the model. In this case, because we've defined this wall to be 11'6", if we tried to make a wall shorter than 11'6", it would give us an error when we went to make that wall. Okay. Another thing to pay attention to within this is the core center line, right? Am I loading this? So how am I loading the offsets within this? So when I make my wall system, you'll see that I'm flipping each one of these, right? And how that's handled. So let's go ahead and make our own here. Now the only way you can make a stacked wall is to start from another stacked wall, right? So we're going to go ahead and come down, and we see stacked wall 1 is our property. So let's go ahead and make a new wall. I can select that wall, and I'm going to change its properties to be stacked wall 1. And if I edit that type, remember when we're editing the type, we're going to duplicate that off. Call it stacked wall tutorial. Then I have wall 1 and wall 1. So by default, this is your out-of-the-box stack, right? It's going to allow you to have 2 separate assemblies, and it's kind of giving us a blank slate to work with. I'll come in, and at the base, which is wall 1, its height is 10 feet. Let's make that height 3 feet. I can do an offset from the bottom. Maybe I want an offset of 3 inches. It's going to move it left and right. We'll come back to that. Same thing at the top. So I have one that's variable, one that's designated. If I wanted to add another assembly, so let's go ahead and click on Insert. That puts that one at 8'6". So why do you think it put it at 8'6" as a default? It's just a default, that's why. Trick question. Now, if I wanted to make the second assembly, the one that's not variable, or the top one that's variable, I need to actually select that wall and say it is variable. So then it switches wall 1 down here to be the one that's actually got a set of information that's concrete, right?
So you can only have one wall that's one type of wall inside the stack wall that's variable. What if there's like
Yep.
2 places where the wall needs
To be variable?
yeah.
Don't do that.
No.
You put a stack wall on top of a stack wall.
You could do that, yeah, you could do that. I rarely see stacked walls used anyway. It's only gonna be when you know, you look at your suburban bank, right, or whatever, or your grocery store, it's got the nice little trim at the bottom, right, for the brick. That's why you would use it, probably the only
Could be
time.
firehouse detail.
Fire, there you go, yeah, I can see a firehouse using that.
Brick veneer on Aegis.
Yep.
Yeah.
Yep. Yeah, so then at the bottom, right, so, and like I said, if you needed to do another one that's variable, chances are you're gonna do another wall with it. I mean, this is just a kind of easy way to go about, if I know I'm gonna be making this wall 40 foot in the air, right, and I know it's continuous around this whole box, right, I'm gonna take the time to make it one wall that handles that whole condition.
Right.
You know, if it's where you guys kind of go crazy with a lot of patterning and everything else, you know, maybe in that case you're just doing separate walls and just leaving it that way. It's really just a matter of what you want to get out of it. So at the bottom here, wall 1, we'll do CMU retaining wall. Second wall, maybe we do it as core. Let's do CMU on metal stud for that one. And then in wall 2, we'll do concrete curb wall 6 inches. All right, so you can see when I do that, each one of these we know has a separate subsystem that's handling finishes, it's handling core boundaries, and you'll see that it's trying to match up core boundary with core boundary. Anytime that you see it match up with core boundary, it's going to make that join in section. So joins in section happen, joins in plan also happen. My center wall, right, is thicker than the one that's at the bottom, so I would need to offset. So I would actually need to know kind of how much I'm off versus the other one and really pay attention to those as system assemblies. So we'll come in, just move that off. I believe it's 3 inches. 2.75, 2'9", 2.75 inches, 0, 2.75. So that's close, right? So it's always going to try and match that up, and if it finds something it matches up with it, it's going to join it in section. Click OK. Click OK. Now you'll see if I go back to the plan, I want to see my walls. Maybe I have my wall finish on the wrong side, right? So I know that my wall finish should be on this other side here where I see the brick. So maybe I'm in a view where that's now facing on the interior. It needs to be on the exterior. There's 2 ways I can handle that. I can come into the properties and I can actually tell it that I'm going from wall center line, or if I move the location line to be finish face exterior, that should flip it. Finish face interior here. Try that again. And it's still going to go that way. So if I need to actually flip the direction of it, I'm going to go back to my floor plan view, top of the second floor, and I'm going to flip the direction of it. So when I select that, find view, there's a little flip direction tool, and it'll flip the side that actually appears on. Now you'll see that the flip,
Is that just for that element or for all the types?
that's for all the
So it's the
wall
same as
types.
editing type and flipping each layer.
Correct. And if we look at the windows, windows are also able to be flipped. So in this case, my window should be facing that way.
So that you're saying when you do that operation, it flips all those fixed windows?
No,
in the
if I
project?
have,
Or
so,
is it just that one?
no, if I copy that, right,
Right.
it's not gonna flip all of them.
Oh, okay.
It's only gonna flip the one.
Because I was noticing in the edit type function, you could flip it there to, if you click on your stacked wall, edit type, there's a flip checkbox.
Yep.
And that must do it for all the types, right?
Yeah, so if so then if I look at that stacked wall we just created, he was asking about the flip direction. If I look at the flip direction tool, what it'll do is say that maybe one's exterior, the other one goes interior.
Yeah.
So, maybe I'm going into an atrium, the other one's not. Within that assembly, right, I can flip that, and that finished face flips, but it doesn't flip the other two. So that's what's happening, is that flip control within it.
You guys start tutorial.
Okay. So any questions on stacked walls? Anything you want to add with stacked walls? No?
No, I think, I don't see a lot of stacked wall work in.
Neither do I.
Design vocabulary, but, I think, in cases where you have consistent horizontal band, stacked walls are appropriate, where you have variable geometry, doing them as separate walls, might be more appropriate. So I think it depends on, kind of what the intent is. Stacked walls, the way they're, managed in Revit are really meant to be horizontal, driven off of levels, driven off of horizontal planes.
So if there's some fancy panelization on a studio game project, you're saying there would be like a basic wall, like the structure, and then this finished face would be a separate wall that stands in front of it, and it's made up maybe bands of different.
Perhaps, yeah.
Right.
Or it might be a curtain wall where you have a module, you have a grid that's defining where that edge is. Or you have physically stacked walls with a lower wall and an upper wall, and then divided by a reference plane. And you're editing the profile, the top and bottom of the walls to control where that change occurs. So I think it would definitely depend on specifics of how you go about modeling, what the best way to model that would be a different answer.
So a curtain wall, the essential difference in a curtain wall and a stacked wall is that the curtain wall you can control both X, Y, and Z of that
Yeah,
plane, whereas
and
a
we'll-
stacked wall you can only control down, horizontal down, and left. Nice.
Yeah. Yeah, and we'll get into, I think, curtain walls in more detail later. Later in probably in that last class.
Yeah, we really,
Walls and panels.
yeah, and
Just to
divided
introduce it.
divided surfaces too. I approach, and we kind of are at that point where to kind of get the basis of curtain walls. I mean, I treat, if we look at this one, right, this is the same thing as this one, only it's modified to suit what we're trying to do with it. So I use the curtain wall tool more as a patterning surface for buildings. When we get into scheduling, it can be an issue. But in terms of design sense, it's easier to manage patterning with it this way and treating things as panels. So I'm taking out gridding and everything else. So I'm subdividing a surface. So I don't see it as an actual curtain wall. I see it as a surface that I can then subdivide to my heart's content. If I need to do any angular kind of divisions, then we're getting into divided surfaces with actual masses and applying panels that way. But everybody's think of a curtain wall, right, is that first one. So let's go ahead and kind of step backwards through this one and go forwards creating our own one, doing the custom one here. So we're gonna go backwards to this one, go forwards to this one. Let's go to the properties of this curtain wall. So it's curtain wall tutorial, curtain wall A is the name of it. Again, it acts the same way because it is a wall. It's acting the same way that a standard wall is going to act. It has a base constraint. You can do an offsets with it as top constraints. The difference is that it has an introduction of being able to divide itself out. So in this case, I look in the instance properties of this particular wall, the number is I can change the number of vertical grids, I can change the number of horizontal grids. So let's go ahead and do that. Maybe make 4 with one and 8 with the other one. And you should see that change. Right now, because when this wall was made, right, that change, we put in our own curtain grid. So that change is not necessarily happening right away with it. So let's go ahead and, so that's our tutorial curtain wall A. Let's make our own curtain wall from that, since this one apparently was modified. Go to wall, so WA for wall. And then we're going to toggle through the properties and select that tutorial curtain wall A first. Let's draw that wall. And then you'll see our gridding within that. And it's putting in the mullions for us, it's putting in the interior mullions, border mullions. We can change all those through profiles. So it really kind of, I think the curtain wall, like Aaron said, getting into it a little bit later, because it is kind of just traveling down the rabbit hole, I'll call it, with how far you can go. So there's a lot of things happening within this assembly. One is you have the wall itself, then we're subdividing that wall, and then within those subdivisions we're loading profiles called mullions. They're sweeping those mullions, and then I'm also within each one of those loading in individual panels into that divided surface. So there's a lot going on within the curtain wall system itself. So it can be fairly complicated at face value. Again, so if I want to change it, maybe I know what the distance is, so I don't want to take my curtain wall and I subdivide it into an equal number of spacings. Maybe I know what that spacing is. I need to go in and edit the type of that wall. And anytime we're doing any editing, we're going to go ahead and duplicate that off. Call it curtain wall B. And click OK. And you'll see more options. So the things I was talking about before, here's where all those other things are coming into play. One is what its function is, what its curtain panel system is. So this is a global for the wall. I can switch out individual panels, or I can do them all at the same time. My join condition, how are my mullions joined together? Am I joining all of my vertical mullions together, or am I joining all my horizontal mullions together? Am I joining the border and vertical, and so on and so forth, or it's not defined at all. It's just going with what Revit decides. Also this layout, so we were able to change the layout by a fixed number. If we wanted to do our horizontal grid, as we know what our height to height is on it, we can do it by a fixed distance. We can say that divide out my curtain wall by a certain number, but only have the maximum spacing be this, or vice versa, the minimum spacing with it. So in my case, I'm going to do a fixed distance for this one. Give it 4 feet. Do the same thing for the vertical grid. Fixed distance, we'll do 4 feet as well with that. Nice squares. Other things you can do with it are loading in the mullions. So down at the bottom, each one of these, and this is kind of going down where there's always a hierarchy of situations, and we haven't got into modeling yet, so understanding the kind of sweep that's happening. So everybody's made a sweep in Rhino or CAD, right? Yeah, so the same thing is there. So you consider the grid line that you're dividing out to be the rail curve, and then your profile is that sweeping element, right? So we're loading in families that house that profile and allowing that sweep to happen. So out of the box, Revit gives you a fairly decent set of items, at least to get you down the road. There's always going to be cases where you need to do custom ones. If you think of, I'm putting a piece of steel on the outside of my window assembly. I'm going to load that as a profile and let that sweep and call it a mullion, not put in individual bracing columns on each one, unless I need to categorize it that way. Okay, so I'm going to leave the mullions as is for that. We can change that a little bit later, and when we put in new mullions. So just go ahead and click OK. So that's going to change our division spacing here. Now, how do I want to justify that? You'll see at the end, I'm making up for a little bit. So it's automatically going to truncate whatever that is at the end. Now, if I want that to go from center on the curtain wall, I can tell it whether or not I want my gridding to go from center or top. So I'm going to bring my top down just a little bit more so you can see this happening. So I have my top is not completely 4 feet and my right side is not completely 4 feet. So I want to justify that and make it from center to center so my ends are equal, kind of like laying a tile floor. I would then, in the instance property, so anything at this point is an instance property of this wall, I'm going to say it's going from center, I'm applying, and that'll shift that justification. So now the center of the wall is where the dividing of that surface happens. Also with justification for the horizontal grid, we do from centers. And then the border condition is what handles that change or that discrepancy in distance. Some other things, so how far do I want to offset that? So maybe I have a case where I need to offset the end. I know I want it on center, but one end I want to shift over 2 feet. I should be able to shift that over 2 feet, right? And it'll make up that distance for me. Same thing with the 1 foot for that one. That'll change that orientation. Angle should shift the angle of the mullions. Right, so if I need to do some irregular pattern, now this some doesn't always work this way. It's very tricky to do angular mullions in any system, so just be aware of that. You can do it. I would sometimes go down the other side, which we'll get into, is dividing the surface out and handling the division that way. Go ahead and click apply. And so we can rotate those interior mullions. Right, so all things are possible with it to a point, right? Remember that it is mimicking a actual building system. So Revit's having a problem, chances are you'll probably might have slight problems as well. Okay, so let's go ahead and then take this guy, and now let's go into kind of creating some other things. So, you know, mullions are what they are. As we get into more family editing, we'll be touching back on more advanced concepts with this, so I can load in different mullion profiles and all sorts of things. If I want to get to the point where I'm at with this one, which is kind of, you know, I call it kind of the more advanced curtain panel. I'm adjusting grids. I want to start with a completely blank slate for my curtain wall. So I'm going to come in and I'm going to do another wall, WA on the keyboard. All right, and that's designated as type curtain wall A. I'm going to change it to just this curtain wall 1. And it's going to say that type generated grid lines will become non-associated due to changes in the type. So basically, I'm going to a system that doesn't have any curtain grid lines. But because I have grid lines existing, it's going to say, do you want to delete them or remove them? I'm going to say delete them, and it's going to take them out. So this is giving me the ability to kind of have a blank slate with my curtain grid system. I'm going to make my own system out of it. When we begin doing our own grid system, the ability to rotate, kind of like we did before, is not available to us. So it's be aware that it's more orthogonal when you're doing your own curtain grid system this way. So to make a curtain grid, right, so we have these 3 buttons here. We'll touch on curtain systems when we get into massing. So curtain grid is here. I click on the button, we'll watch the graphic before we go ahead. So it's going to allow me to subdivide that surface in an irregular pattern. Now to lay any horizontals, right, I'm going to have to hover over a vertical, right? And in this case, the only vertical I have is a boundary condition. Do you want it? we'll get into that.
Or how
How can you?
For
Yeah.
some reason, the guy that changed the type curtain wall once still is bringing in horizontal, even though there's nothing showing up here.
Okay.
He's got the perimeter lines.
So let's see here, tab through. So in the case of Will, right?
Yes.
Yes, good. In the case of Will here, he's still got grid lines, even though he came in and he switched out. The grid lines stayed. And in my case, I've added in grid lines. So grid lines work in so far as that I can push and pull them if I unpin them. So the first thing is remember yesterday, pinning and unpinning. If your grid lines are pinned, so they automatically come pinned from a situation, you'll want to unpin them. So, and I'm tabbing through to grab that line. So remember, we have multiple systems here. So I have one, the whole wall, which is there. Then I have individual mullions. Then I have grid lines.
Attention down here to what you are selecting, right?
Yep.
And when grid lines are pinned, that means that they're behaving based on the rules defined by the wall type.
Yep.
So they're behaving by these rules. When they're unpinned, that means
They're loose, so I can go.
free-flowing grids.
Yep. So you've got them deleted?
Yep.
So yeah, exactly. So once they're unpinned, I can then come in and actually delete them. So again, as Aaron said, pay attention to what you're tabbing through here. I know, and it's a little more tricky with the grid lines. If you look closely enough, it should be a dotted line for that grid line. And if I select that grid line, I can always delete that grid line off. If I want to move the grid line, I can tab through and grab the grid line. I'm grabbing all of them right now. If I grab one single one, I get my editing dimension, so I can move my grid line from one to the other. So maybe I want 4 feet from the edge of the other one. And it's always, when you grab one, if I tried to move this next one, right, I have to move the next one as a distance from the other one, or I can do vice versa. So paying attention to where it is at the ends is always tricky with that. If I want to delete out specific segments, so in this case, I want to remove this segment on my curtain grid, I'm going to tab through and grab that grid itself, and then I can add and remove segments. So you'll see at the top right, I can add and remove segments. Click there, and that'll actually remove a single segment, or I can remove multiple segments by deleting the whole piece.
So we get that. So you get the context menu pops up only after you select a grid. So first select a grid, and then you'll notice the green menu up here that's a context menu that's specific to what you selected. Then that'll allow you to add and
If I want to come back and add in grid lines, so now let's go ahead and move this guy a little bit. Back so you can see it more. So if I look here and I can see maybe I want some more gridding at the top, I can come back and add my curtain grid as one segment.
So after you click add remove,
Mhm.
what do you do then? I mean, because it's just a big gray.
So if I want to, so I need to always have it's what Aaron would call noun verb. So I need to actually grab something and then do something with it. So if in the case of the horizontal, right, if I want to remove more segments, I need to actually select the grid line, and then I should be able to move it.
So it's actually just deleting. When you click this button, it's only allowing you to modify the one grid line.
Yep, one grid at a line at a time. It's not.
It doesn't activate the entire.
No, not at all. It'd be nice if it did,
Okay.
but it doesn't. Yeah. And then if I want to add curtain grids, right, I can select that curtain grid tool again. So I'm under architecture, and I can do all segments. So if I do all segments, it's going to add for all divisions, or if I do one single one, it'll allow me to only go over that panel division. Right. and then I can do all except pick. So maybe I want all except that one. And I say that I want that one. And then I say okay. Right? So the all except pick is probably the trickier one to manage. So if I want to, so now that I have my gridding system figured out, is now accessing the panels. So the panels themselves can also be flipped out within them. And what's nice about starting with the curtain wall system versus doing starting with a curtain wall versus a curtain system is within this one I can actually load in, as we were talking about earlier, is if in the case of a stacked wall, I could also load in panels of walls within this. So take the top right. So to access the panels, there's two ways I can do it. I can tab through until I access each panel, right? Or I can come in and select all the panels at once, and again use my filter tool. In the case of one that's been driven by a subdivision, I'll need to do that this way to unpin those panels, right? So I select it and do unpin, right? If you're dividing it out manually, as we've done here, the panels themselves will be automatically unpinned. And when I select the panel, you'll see that it's now a system panel, SGA exterior glazed. I can make our tutorial stacked wall into that, right, that we just made. I can load into it. I can tab through, add in just a standard wall. Right, so the ability to really start patternizing or putting patterns to building systems is here. It doesn't have to be straight curtain wall is curtain wall. You can really begin kind of pushing and pulling what you can do with it. I always like to show that, even so as within the bigger panel that I have here, I can take one of my existing curtain walls that I've created, this one, curtain wall B, and actually load that into that one, so I can begin fractaling those panel systems. So really it is just a pattern tool, and you'll see, because that was a system that was driven by actual division properties of the curtain wall, I need to unpin that panel, and I can change that as well. Curtain wall 1 or curtain wall. Right. One last portion is if I wanted to load a door. So most people come in and say that, I know it's a wall, I'm thinking that I'm going to be able to load a door into it, right? But because the curtain wall is an assembly of glass and it's kind of unique, it's not going to accept that normal door hosting element. So I have to create doors and windows and turnstiles and everything specific to this particular system. So to load a door into this, it has to be a designated curtain wall door. And by default in here I have one loaded for you. Revit out of the box comes with a few as well, and I'm sure SGA family libraries have them as well. So I can select a panel. The way to do it is you treat the door as a panel, just like it's a wall panel, and I tab through. And I'm going to do my curtain wall double glass and load that in. Now, there's another little trick. If I wanted to not have to rebuild my door and just kind of get the drawing out the window, and it's like a wooden door in the glass curtain wall system, I can still load the door into these wall panel systems themselves, right? So I can still do that as well. So once I have a panel that's a wall, I can actually still load other objects into it, and it reads that as a hosting element. So you can, I find probably the most, for at least skinning a building, the curtain wall is probably the most versatile because it allows me to panelize the systems and push and pull with it, right? Because if I want to, if I'm doing design iteration, I want to see, how big this may be this way, what it looks like across the whole system. I can do that relatively quickly. Okay.
Notice your curtain wall door family is driven by the grids in the same way the other panel.
Oh, it's just
driven
the
by
shape.
the grid separation. So if you wanted a 7-foot high door, you have to drop a grid at
So what I need to do to access that, just like we loaded other panels, I select my panel, and then it's loaded as if it were a wall or a panel. So it's a panel within the family. So you'll see a designation that says the global type property, global family, and then the regional
I see.
of it. Okay. And we can lock these. You can host these to reference planes. They can be aligned to reference planes. So if I'm doing layouts on a building skin, and I know that I'm gonna have irregular divisions, instead of trying to go in and tab through and grab the curtain grid line every time, I'm gonna make a series of reference planes and align and lock them so I can push and pull dimensions that way a lot quicker. And that kind of leads into building families and so on. Okay. Is there any other questions for curtain walls with this that you guys have?
So you have to make the panel the size, the opening size of the door before you can insert the door. Otherwise, it will change the proportion of the
Yeah,
door.
yeah, and there's gonna be cases where they fail. So if I select this one, obviously it's probably gonna be too small for the family that was created, and we'll get into kind of, well, I guess not. Let's try this one. There are cases where I'm gonna try and make this break here. Okay, I'm not gonna be able to make it break now. There will be cases where it breaks, and it will tell you cannot do this.
So that the height of the door is controlled through the type, the door type, right? So how does that? Why does the curtain wall allow that type to change its properties
The height of the door.
The height of the-
is controlled by the grid.
By the grid line.
by the grid, not by editing the type of the door?
Yep.
Curtain wall doors are different.
They're treated as panels.
They're walls, basically.
They're they're
panels
they're
that
panels.
fit inside of a grid structure.
A grid
Yeah.
structure, right?
So, and kind of and we're definitely going to do this today. We'll build a little box after we do our little family editing portion and building a little box. We'll take that same box and push it into this curtain system and have those grid lines drive the actual depth to get a random surface out of it.
I mean, it's just the way it's built. It's the same as the way it's built, basically.
Yeah, it's just, like I said, it's just an extrusion. It's just a panel within that. So, and this is another thing. For any kind of blank system, right, I can edit that and push and pull it all I want. So I've seen it. I've done it where I've loaded in, columns into my curtain grid system. I've made an empty panel. That's another thing we didn't do on it. If I want to make a hole in my curtain system, there is an empty panel. So I'll come in and try and find, looks like my empty, it's not loaded. There should be an empty system panel. Yeah, it just loads it in as a void. There's nothing there, right? So, and I can do a whole line of these, and if I know I have structure, or I'm facing, I have my column coming up on the outside skin, and then I'm using a panelized system that's wrapping that column and bringing my curtain wall with it. I'm gonna put a blank in it and either handle it with the column, or I can actually load a panel that's acting as a column into my curtain system, which I've done also. In terms of scheduling it, there's trade-offs for everything we do. Just be aware of it. We had to eventually switch those out and put real columns, but up until DD, that was fine. So.
I think a good thing on walls, Craig, if, attaching the top and bottom.
Good point.
Maybe doing a flat floor and then maybe a slope floor above, if you're showing how to control walls, going to the other side.
Yeah, that's a good point. So, and what Aaron's kind of alluding at is I'll do the nice little gable and a floor. So, when we get into cases where you need to have the wall, you think of the house. The house has the gable, the wall needs to come up and finish up the whole piece. So let me quickly make a floor and a roof that does that. So let's go floor plan. So we'll make our floor. floor. So I'm making my wall. If I go to 3D, let me put the wall in there. The wall comes across. Make that not a curtain wall and actually make that a standard wall for this. 3D. There we go. So I have my roof, and then I have my floor. The wall obviously comes up. There's two ways I can handle this. I can come in and I can edit the profile of it, but then I have to go into an elevation view. I have to make sure I snap it, and then anytime this changes, I have to make sure I go back and change that profile. What's nice about the walls is I can also attach then to the top of that roof, and it's going to cut that wall for me. Then it works with floors, works with ceilings, all of those other pieces. So then when I move my roof up or down, let's try and get that down. I'll go to 3D. Right, it's going to change that wall with it as well. Same thing works at the bottom. Attaching this to a floor, maybe there's another subfloor that came in, so I can attach and detach the base of that. So joining the
It's attached top
Yep.
slash base, that's the approach.
yep.
And would you, the other way to do it, I mean, would you prefer to do it that way in typical like flat slab construction where you have a stud wall going up to the bottom slab, or would you use a reference line and align the wall to the reference line?
Well, it really depends, I think. You'll notice that in this case, even though I've attached it to this roof, that's still showing it as unconnected. So, I mean, there is the ability to still kind of edit it slightly, so I can, 35 feet, it's going to bring up whatever part that doesn't cut. I mean, if I have the time, I still like making a reference plane for the tops of my walls, just so I can control them. But then again, it depends on where I'm at in the project. If I'm just producing a Revit model to make a rendering, which to you guys probably sounds crazy, because most of the time you're going to go to Rhino or something, but I'll go to Revit all the time. I'm going to just host it to the level line and go with it, because I don't need to have that level of detail. It's kind of like going into the wood shop, right? I need to show the massing of this table I want to build. I'm not going to go and actually bandsaw and bevel the edges of that table. I'm just going to table saw the thing out and be done with it. It's not until I'm, go into, I'm going to go to the lathe and turn the legs, I'm going to slowly build up to those moves. I'm not going to do those right away. But yeah, I still always like the reference plane.
Yeah, if you were starting, you can easily, go to the 3D view, go to some view, select all your walls on the floor, and make their top constraints to a specific offset from a level. Let's say you have 6-inch slabs, your top offset would be minus 6 inches for all the walls. That's simple. I don't typically attach bottoms of tops of walls to geometry unless I have sloping conditions and profile conditions, because it adds a constraint to walls that and it's part of being an efficient modeler or efficient Revit user. File size gets big as you'll see when you start to lock and constrain things. Oh, that's really fun. And then with this, now everything reacts off of that. Well, that adds processing time, save time. Again, builds that little Swiss watch that if you change one thing, then you break other systems. I like to keep things. I like to minimize the amount that I constrain within that model. So I typically constrain really, really important things. Grids and levels, certainly. Controlling geometry, the exterior walls relative to easements and property lines and things like that. Then I'll lock down. Most everything else, I want to be able to flex and move. The nice thing about these reference planes, as long as they're named, I think that's a good way to go because you can adjust that reference point, but, and then control, types of, a lot of molds that way. But again, too many reference planes in the model starts to get a little crazy, and you get hundreds of different controlling geometry lines in the model, and they're very overly complex.
Yeah.
So a lot of times when I'll start is I'll just say level 2 to level 3, 12-inch offset, negative 12-inch top offset. And then top slabs.
Yeah. Yeah, it's always, and I think you guys, as you go through it once or twice on a project from start to finish, you'll really begin to really understand when it's appropriate to do certain things. Yeah, I've walked on the projects where there's numbers of reference planes and they're not named either, and you have like 10 within the same little bunch, and you don't know what the heck they're for. And then if you go to delete them, then all of a sudden a bunch of warnings are up. So either way, it's going to get complicated no matter what you do. So. Okay. All right. So we definitely will build on this a little later when we do a family, because I'd like to show you how those families can react to existing things in projects, and how we can push and pull and allow data to actually drive the model. So we'll come back to this file. You can save it to the desktop. And then when we get back from break, we'll come in and actually start filling out a floor plan. So we'll pick some lines on walls, start laying it out so we have some things for you guys to work with as we move along with this. Yeah, so if you guys want to take a 5-10 minute break, and then we'll hit it back. Make sure you save this file to the desktop, please. Thanks. And then you can close it for now.
All right. Good luck.
Thanks, Aaron.
Class, I'll see you guys probably tomorrow and also Monday.
Okay.